Hello students. So today is the last session for physical world. First I will explain to you what is unification of forces. It's a small topic, and then we will go to nature of physical and laws. Now unification word I had explained to you that it means uniting. So we have learnt last time that there are four types of forces. Now attempts are being made whether we can unite these four types of forces also and convert it into single force. Further simplify. So far success has been obtained in connecting electromagnetic and weak nuclear force into one force called electroweak force. So electroweak force is a combination of weak nuclear force and electromagnetic force. Now still attempts are being made to connect strong nuclear force also to weak electro force, and further to connect gravitational force with them. In past also various forces were unified. I have given a few examples like physician Isaac Newton. He made Newton's law of gravitation. So it is applicable for celestial bodies as well as terrestrial mechanics. Like moon rotating round the earth is explained by this law. Satellite rotating round the earth is again explained by this law. Bodies falling on the earth is explained by this law. So there are various types of physical phenomena that can be explained by this single law. Then second example is that physicist Oersted and Michael Faraday both had told that electric and magnetic phenomena are inseparable, so they combined the two and they gave the word electromagnetism. Mr. Maxwell further unified electromagnetism and light, because light is also an electromagnetic wave and electromagnetism also has electromagnetic waves. So in this manner this unification was in progress since long. Is it all right? So then we will go to today's topic, nature of physical laws. Now first you should understand what do we mean by conserved quantities. Now you see, when various forces act or when various bodies interact with one another, then many parameters change, but there are certain parameters that do not change, that remain of the same value. So they are called conserved quantities. I will give you example. Free fall of a body. You have learned this in the 10th standard, that if a body is dropped of certain height, at height it is having potential energy. When it reaches the ground, it is having full kinetic energy and no potential energy, and both are same. At any intermediate point, potential energy plus kinetic energy, if we add, we will get the same value. So we say that mechanical energy is conserved. In case it hits a ground or hits a cemented floor, then it may produce sound, it may produce some heat, and this heat will go in the air surrounding it. So mechanical energy may not be conserved, but total energy of body and surroundings, these two things is called a system. So total energy of the system will remain constant. So this is very important, because there are many examples, there are many physical phenomena in which law of this conservation of energy is valid. They can be microscopic bodies or microscopic bodies. For all, law of conservation of energy is valid. Now we consider full universe. If we consider full universe, there are various bodies which are interacting with the atmosphere, earth system. So total energy of universe will remain unchanged, because if certain body is losing energy, the other body is gaining the energy. So we say that total energy of universe remains unchanged. Another example is of chemical reaction. I think I told you last time also, when two substances or molecules react with one another, this rearrangement of atoms. If we neglect the binding energy of reactants and products, because they may not be equal, but the difference is quite small. Its conversion to mass would be very negligible mass. So we say that mass of reactant is equal to masses of product. So total mass of reactant is equal to total mass of product. So this is law of conservation of mass. Now, what is the advantage and how it is useful, conservation laws? You see, in many physical phenomena, we may not know all type of forces, or we may not have full data. Then this gives us one equation. We will use this equation that okay, energy is remaining constant or mass is remaining constant. So we will come to know the unknown. So it is very useful in quantifying our physical phenomena. Like suppose in case you heat something, it forms gas, it goes off. Then you have got residue left. What is the amount of gas left? You will use law of conservation of mass. My initial reactant was 20 gram. Residue is 6 gram. So 14 gram of gas has left. So in this manner, in various numericals, we will be using such conservation laws. Mainly physicist W. Pauli Vittai had used this conservation of momentum and conservation of energy, and he told there is some other new particle is also emitted along during beta decay. So then he verified this by using certain experiments, and he found this. So in this manner, these laws are quite useful. Now let us try to have a list of various laws. I have made a list. We can have conservative of total energy of isolated system, of linear momentum, angular momentum, mass plus energy, charge, conservation of nucleons. Now first three are important because they are from mechanics. About angular momentum, we will be learning when we learn a chapter of rotational motion. Okay. Now, what is symmetry? We say in nature we have got symmetry for time first. What do you mean by symmetry for time? It means like today, under certain conditions, you are carrying out an experiment, you have got some result. You carry out the similar experiment after n number of years with the same conditions, you will get the same result. So we say that nature is symmetrical with respect to time, and from this symmetry we can prove conservation of total energy of isolated system. Those proofs are not in the syllabus in 11th standard. They will be when you are doing BSc or higher physics. Even in 12th they are not there. So from symmetry of nature with respect to time, we get conservation of total energy and isolated system. This you should learn. Similarly, we say nature is symmetrical with respect to space. It means if you are carrying out an experiment in one place, you are getting some result. If the same experiment is carried out in another place under same conditions, then you will get the same result. So from this symmetry of nature with respect to space, we can, if we get equivalent conservative law of linear momentum. So this law we will get conservative law of linear momentum. Now, someone say, no, it is not same. Like today, if you take a mass of a body in earth, suppose it is 60 kg, but if I take that body in moon and find its mass, find its weight, I may get only 10 kg. So here it was weighing 60 kg, in moon it is weighing 10 kg. So you may think, this law is not applicable in different places. No, law of gravitation is applicable. Conditions are not same. Mass of earth and mass of moon are not same. So if you put the values in Newton's law of gravitation, you will get the correct answer. Then other symmetry is of isotropy of space. Isotropy of space means like you can carry out the measurement in any direction, east, west, north, south, northeast, anywhere, you will get the same result. So this leads to conservation of angular momentum. So this thing you should learn, that which symmetry is used to prove which law. Okay, so that finishes this topic of physical world. Thank you.